here we are told to find the intersection of complement of A and B. First, let's shade A, and we recall the complement of a set is the set of all elements in the universal set that are not in that set. In this case, to find complement of A is simply all the areas that are not in blue. Let's now shade it with yellow. Now we can clearly see what is A prime. We can remove the original blue color representing set A. Now let's draw set B with red lines. The intersection of A prime and B is simply the areas that are in both yellow and covered with red lines. Now, given a Venn diagram, how do we shade the complement of A intersect B? Well, we know the intersection of A and B is the common area for both A and B, referring to this area shaded in green. And the complement of a set is the set of all elements in the universal set that are not in the set. This means all the area inside the rectangle that are not in green. Now that you have shaded yellow for this area, you can safely remove the green area, and this area shaded in yellow is the answer. The sets A, M, and B are given by the following definition. A is a set of students in the class, M is a set of students who study mathematics, and B is a set of students who study biology. Express in words the set that belongs to the following. Now let's do A first. What's the set considering of the intersection of M and B? Now let's draw a big box representing A, the universal set, which represents the student in the class. Inside this box, we draw a circle to represent M, student who study mathematics, and let's shade it with yellow. And next, let's draw another circle, B, to represent student who study biology, and let's shade the circle with blue. The intersection of M and B is basically this area in green that represent the overlapping areas. They are the students who study mathematics and biology. Now the next one requires us to first find the union of set M and set B, and then we take the complement of this set. Let's do this step by step. First, let's shade all the areas that is in the union of set M and set B, meaning the circle in yellow and the circle in blue should all be shaded. Now that we found the union of set M and set B, the complement of this set is simply all the area in the rectangle that is not shaded green. Let's shade this with the color red. You can see that the area in red represent the complement of the union of set M and set B. They are basically referring to students who neither study mathematics nor biology, meaning students who did not study mathematics and they also do not study biology. Now the last one, let's find the intersection of the set M and the complement of set B. First, let's identify what is the complement of set B. We already shaded set B with blue, and you just have to exclude all the area that is in blue to find what is the complement of B. Let's shade this area with red lines. And then you can see The overlapping areas of the red lines and the yellow area will be the intersection of set M and the complement of set B. These are actually referring to students who study mathematics but do not study biology. Now, this is the last question for set theory. Exercise: let the universal set be defined as x is an integer where x less than or equal to 20 and x more than or equal to 1. We have the set A defined as odd numbers and set B defined as multiple of 4. These are elements in A, these are elements in complement of A, these are elements in the union of A and B, and these are elements in the intersection of A and complement of B. Take some time to do this by yourself, and I will go through with you in a short minute. Are you done? Let's do this one by one. First, let's list the elements in A. We know A is odd numbers and it must lie between 1 and 20. So A will be equal to the set containing 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. The complement of set A is a set of integers between 1 and 20 that do not appear in set A. So making sure that we have the right list, we just have to make sure whatever we write down here do not appear in set A. Now we have the complement of set A to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Take note that 20 is included because x is inclusive of 20. And note that every element you can see in the complement of A here is not in set A. Now, how to find the union of A and B? The easiest way is for you to first list what is B. B is multiple of 4, so B is a set containing 4, 8, 12, 16, and 20. And so looking at set A and set B, you could easily combine the whole set to give you the union of set A and B. And we have the set of union of A and B defined as 1, 3, 4, 5, 7, 8, 9, 11, 12, 13, 15, 16, 17, 19, and 20. The last one, how do we find the intersection of set A with complement of B? Let's just write down the complement of B. The complement of B is 1, 2, 3, 5, 6, 7, 9, 10, 11, 13, 14, 15, 17, 18, 19. Now we just have to see which elements appear in both A and B prime. We have the intersection of A and B prime to be the set containing 1, 3, 5, 7, 9, 11, 13, 15, 17, 19.